Good morning. The project is Electric Vehicle Fleet Management, short title. The project team is me with manager, our software developer, and Saman Ahmadi, who is working specifically on optimization, network optimization. Also, Mohammed Kazmin and Patrick help us a lot during the development of project. Before I start, especially welcome to Mohammed's parents. Fleet managers, why? First define the fleets. Fleets a group of vehicles that an organization such as Post, Australian Post, DHL, Ventura Bus, they have a group of vehicles that need to manage. So why they need to transit from traditional vehicles to electric vehicles? There are some benefits. The first benefit is net zero goals. For example, each electric bus generates up to more than 50K CO2 emissions per year. Suppose that in Melbourne we have a lot of buses. If we replace them with electric buses, we maybe reduce the emissions a lot. Lower fuel cost. I made a comparison between a small EV with a small gasoline car. Here, just for 100 kilometers, approximately the cost for fuel for electricity is just $3, but for normal car is maybe $16. So we have, if we replace the EVs with cars with EV, we have reduction in fuel cost, and also EVs require lower maintenance compared to gasoline or traditional cars. But it's not easy, this transition, because the first challenge is availability of charging infrastructure when you need some charging station to charge your car. Also, there are some other costs, range anxiety. You may have some anxiety to maybe at the middle of your road, the charging is maybe you have no electrical charge and you cannot find easily a charging station. So maybe the EV fleet managers have some anxiety about this. There are two main tasks for for fleet owners to transit to electric vehicles. First is EV fleet planning, which are not we don't focus on it right now. We just focused on EV fleet scheduling. The EV fleet planning means that before you transit to electric vehicles, you need to, for example, you have a limited cost, limited budget. The EV fleet management suggests you some options, which car you need to buy, which set of cars, which brand, Tesla is better or BYD is better. Each have some benefits and some disadvantages based on the maintenance, based on the price, based on your budget. Another is when you have EV fleets, you need to care about scheduling. Every day these fleets start from a point, a source, and then have a route, have a journey, and then come back to the depot. So we focused on this part. There are for traditional scheduling, traditional car, we just care about routes and time slots. But for EV scheduling, we need to care about the charging times, where and when they need to be charged. We need to care about the state of health of battery. These batteries, after a time, maybe their health may be reduced, such as our smartphone batteries, maybe for the first year is perfectly work, but for the second year not, maybe reduce the state of the health. We need to care about these two factors. There are some existing fleet management software. Each organization does have fleets. We uses some services from some fleet managing software such as Fleeto, such as Geotab, such as Optibus. But most of these fleet management systems are not specifically designed for EV fleets. We need to, their schedules are just for normal fleets, not for electric fleets. So here, our main goal is to provide them as an add-on service to let them electrifying their fleets easily. So here we first, so we don't generate or we don't develop whole parts of the EV fleet management system. We just develop an add-on to existing software fleet management systems. We just get the normal routes from them, and then here convert that route, the normal route, to a graph, and then develop some optimization, network optimization problem, and then solving this optimization problem, and then return the EV scheduling to the EV fleet or to current fleet management systems. Our case study, because we have the data from electric buses in Melbourne, so our case study here for showcases for electric bus. The Ventura bus in Melbourne currently have 27 electric buses with 28 charging stations now at this moment. All buses now charge at the depot. They don't have any en route charging. There is the problem. We visited their depot and saw maybe we have a look at the charging station. 427 electric buses is sufficient. But if they want to increase the number of electric buses, this charging station is not enough. They need to charge the electric buses during the route, during the day. So that's why they need our software. We, as a part of our study, because there is no charging station infrastructure for electric bus across the Melbourne. So for establishing just one charging station, for charging equipments, for just one charging equipment, it requires between 1.5 and 3 million per station. Include electrical infrastructure, need to upgrade some grid, local grid, also need some civil engineering tasks to prepare the sites for, so maybe the total cost may be higher than 3 million, maybe near just 5 million just for one charging station. So we have limited budget. Our first goal was to just prioritize what is the best location for charging stations. We identified those possible locations for charging station. Here is in Melbourne. We identified, we get the data from PTV. We identified the bus stops, the possible stops. They are all possible locations for charging station. We developed, we converted these data to a graph, to a network optimization graph, for the two goals. First, identifying the best location for charging station, then reschedule the bus routes and electrifying the current route and add some things in their routes that when and where they need to be charged based on the current schedule. We used Amazon EC2 for running our optimization problem. Here is some of the results. For example, if the end of trip SOC, at the end of when buses ends their trip, we expect that, for example, 20% charge they have at the end of the route, or 40% at they have available charge based on the different constraint, different number of charging station need. For example, if just we want to expect that 20% of charge expected to be at the end of the route, we just need 36 charging station for the whole Melbourne. But we expected, for example, 70%, we need 94 charging station. These studies are based on the weekend and weekday profile because it's different based on the number of passengers. And here's a part of our software. We ranked the charging station if public transport, for example, here PTV wants to establish charging station. They are all possible location, but the first rank, here is the second rank, here is the first rank, is very, very important critical point. This one is second important, this one is the third important. So based on their budgets, they can make good decision to establish the charging station. It's the first part of our study. The second part is we developed a web application based on AWS framework to get data from existing fleet management software and then return them the routing with charging, with when and where these fleet need to be charged. The current work is a web application. We define some forms. Manager will show you. To define schedules or routes. The second part of our software is we can get schedules from in the form of JSON files. We develop a optimization task for a schedule. These optimization tasks run by EC2 or it's run under different jobs. Each schedule is a job, and then they are in a queue, run one by one. It's required time. We also developed, just provide you some showcases how this software works. Manager?
Yeah, sure. Hi, everybody. My name is Manager, and I am PhD student at Engineering School of RMIT. This is our application for EV Smart Fleet Management Systems. We have different parts. For example, we develop a dashboard to manage current scheduling. You can create a new scheduling and define new one. You can at this part import some predefined schedule to the systems, and you can here manage the existing ones. For example, here I select the one that their status is ready to show.
Just manager, just explain that form. What is that form?
Okay. Here we select some scenario that we have a source location that you can see here at the top, and here is destination location. And this is a fleet management. We start one location, and we may have a different trip. And here you can see we have a several trip. When we start here with the charge status, for example, 380, goes to next stops, and you can see the charger status at each stop. The part that is important is here. We suggest that in which stop you need to charge the EVs. For example, here, you need to, for example, charge EVs for 3 minutes, here for 2 minutes, and at this stop, you need to charge for 3 minutes to be This is important based on the scenario that you define in previous.
Thank you very much.
Thank you.